Hello, Algebra 2 students. We are doing adding and subtracting rational expressions today. So before we started, I wanted to talk about how this is different than the multiplying and dividing. All right, so the key things about what's different about adding or subtracting as compared to, a little multiplying and dividing, right, is that multiplying and dividing, you don't need a common denominator, whereas here, we are going to need common denominator. And then the second thing is you can't simplify until the last step. So just some key things to keep in mind. Just like we did the other day, let's start with a simple example so you can kind of see what's going on here. So I want to start with 4/9 plus 3/8. All right, to be able to add fractions, what I'm hoping you remember is that you need a common denominator. So that needs to be our first step over here, is to find a common denominator, which I'll often just call the CD here. So if we're looking for a common denominator, typically we would look to see like, all right, do they have any factors in common? So if I think about factoring this, 9 is 3 times 3, 8 is technically 2 times 2 times 2 when I factor it all the way down. There's nothing in common. So the common denominator needs to include all the factors here. So we need to include the 3 and 3 here, as well as all three of those 2's. Well, essentially what we're just doing is multiplying 9 and 8 out, and I would end up with 72. So when in doubt, if there's nothing in common between them, you just multiply them together to get the common denominator. From there, once we figure out what our common denominator is, we're going to multiply each fraction by a form of 1 to get it over the common denominator. So instead of 4/9, what I'd want to look at is, all right, well, what do I need to multiply by so that this will be something 70 and that will be something over 72? Well, here I would need to multiply by 8/8. So this would give me 32/72. And I would multiply this one by 9/9. And this is equivalent to then 27/72. So equivalent fraction, just now with the common denominator that we want. Once you have a common denominator, then you can add the numerators. I'm going to say add or subtract because it's going to be the same rules for either. The numerators and keep the common denominator. Don't change anything there. So now that we have the same denominator, we can just add these together. So 32 plus 27, that's going to give us 59/72. And then your last step should be, can we simplify it? So that was this here. Wait until the end to see if it simplifies. So check to see if you can factor and simplify. This particular one, 59 is not going anywhere, so we are stuck with 59/72. All right, now let's talk about some examples where we have x's in here and we couldn't have just done this on the calculator. So if that was our first example, we'll make that example 1. Let's do example 2 here. So I'm going to give you 3 and then over 4x plus 1/2x squared. All right, to be able to pick out the common denominator, we mentioned it has to have all of the factors here. So in this case, this one is 4 times x. This one is 2 times x squared. If it helps, you might want to think of this as 2 times x. And then here, this is 2 times x times another x. So if I have two 2's here, then both of them have to make it in. And I have a single x there. All right, now when I come over here, well, it's already got 1, 2 in there, so it's good. It's got a single x, but it doesn't have a second x. So I need one more x to account for all of these denominators being present over here. So now when I look at it, 2, 2, and x is covered. 2 and 2 x's are covered. So when I multiply that out, this is just 4x squared. All right, now that we have our common denominator, our goal is to get each fraction over that common denominator. So you have to think about, what do I need to multiply it by to get it from 4x to 4x squared? Well, that first fraction is just missing another x. So we're going to multiply this guy by x over x. That will make that 4x squared. That'll make this 3x. Over here, to get from 2x squared to 4x squared, I just need to double it. So if I double the top, double the bottom, that now gives me 2, and then over that 4x squared. So just getting equivalent fractions. Now that I have a common denominator, now I want to add together the numerators. So 3x plus 2 over 4x squared. And then this, I can't factor that any further. There's nothing more. I'm just going to box it in and call it a day. That is my answer there. All right. Let's try it now when we have polynomials in the denominator. So for our third example, I'm going to give you 4 and then over 5y minus 15. And then plus 5 over y squared minus 9. All right. Let's look at these in factored form, the denominators in factored form. So I can take out a GCF of 5, and this would be y minus 3. I can take the difference of squares here and get y plus 3 times y minus 3. So when I pick out my common denominator, it has to include all of the factors. So since there's a 5 and a y minus 3 from this first one, it has to have 5 and y minus 3. From the second one, it needs to have y plus 3 and y minus 3. Well, the y minus 3 is already there, so it's just missing the y plus 3. So make sure that it includes all the factors that are listed in the denominators here. You'll know if you picked right if this next step, becomes pretty easy, because what your goal is to now get it over that common denominator of 5 times y minus 3 times y plus 3. Same thing here, get it set up, 5, y minus 3, and then y plus 3. All right, take a look at what you're missing. This one is just missing the y plus 3. So I have to multiply the top and bottom by the y plus 3. So times y plus 3 here, and then times y plus 3 here. So when I bring this down, this is going to be 4 times the y plus 3. Distribute it as you go. Make your life easy. So this becomes 4y plus 12 over here. The denominator already has the y plus 3, y minus 3. It's just missing the 5. So we're going to multiply top and bottom by just 5. So in the top, 5 times 5 is 25. In the bottom, now I have what I need. So there's the equivalent fractions, just now with the common denominator. All right. Now that you have the same denominator, keep that denominator and let's add those numerators. So 4y plus 12 and then plus 25. So when we put that together, that's going to give us 4y plus 37. That is clearly not factorable. So once I get my one single expression, I've added my terms and I'm done. That's it for example 3. All right, for example 4, we have x minus 3 over 2x plus 1, and then plus 4x over x plus 4. All right, I like this example because when you look at the denominators, there's nothing to factor. So if this is the simplest form, same here, consider that factor all by itself. So when I go to pick out my common denominator, it has to have this factor of 2x plus 1. And then it also needs to have this factor of x plus 4. So we just multiply them together to create the common denominator. All right, set it up. 2x plus 1 times x plus 4. Same thing here. 2x plus 1 times x plus 4. Let's think about what we're missing. So to get from here to here, I'm missing the x plus 4. So we're going to multiply this by x plus 4 and this by x plus 4 to get it here. This top part, because it's a binomial, throw some parentheses around it. We're going to actually have to do a little box multiplication here as we bring it down. Or, of course, you can FOIL. Right? So as you do this, you can do the work off to the side if that makes it easier. So x minus 3 and then x plus 4. That's going to give me x squared plus 4x minus 3x minus 12. So x squared plus x minus 12 is my new numerator. For the second fraction, I have the x plus 4. I'm missing the 2x plus 1. So multiply by 2x plus 1 and 2x plus 1. And in this case, when I multiply this out, I'm just going to distribute. So 4x times 2x is 8x squared. 4x times 1 is just plus 4x, right? All right, once we have them both over the common denominator, let's combine this here. So we should have x squared plus 8x squared, so 9x squared. 1x plus 4x, so plus 5x, and then minus 12. All right, you want to try and factor that to see, could I simplify this fraction any further? So if we take 9x squared plus 5x minus 12, this would be some sort of maybe slip and slide. So I'd have to take that 9 and multiply it over. So x squared plus 5x, and then it'd be minus, 108. If you go into your calculator and try to do it, it's not going to work. All right. So I'm just going to write a little note to save us some time. It's not factorable, but I bring it up because if it was, I'd want you to factor to see if anything could cancel further. Otherwise, we can stop right here. And that is our answer. All right. We have a few more examples. And this next one, we get into some subtraction. So with this, I give you 1 over x minus 1 minus 1 over x. All right. When you look at this, there's nothing to factor here, nothing to factor here. So consider the x minus 1 a factor itself, the x a factor. If you need to put parentheses to remind yourself of it, go ahead. So when you choose your common denominator, it has to include all the factors. So it has to include the x minus 1 from over here and the x from over here. Right? Or maybe you write it like that. Right? Let's get ourselves over that common denominator of x times x minus 1 and x times x minus 1. Let's think about what we're missing. This first one is simply missing the x, so multiply top and bottom by x. So that makes it x over x times x minus 1. Here, this is missing the x minus 1 factor. And so multiply that in and bring it down. We'd have x minus 1. All right, here's where things change a little bit. You have a subtraction sign in between. So now that we have our common denominator, we're going to keep the common denominator, but you're going to remind yourself that if it's subtraction, I'm going to subtract the first term and the second term. So you have to distribute that subtraction through. So this becomes x here, and then minus x, and then plus 1 when you distribute that minus sign. All right. X minus x, well, those cancel. And I just end up with 1 and then over x times x minus 1 here. And that's it. All right, the next one, I want to write it down. And we will start class with it tomorrow. So last question. Whoa, there we go. All right, give yourself x over x squared minus 4 minus 6 over x squared plus 8x minus 20. Feel free to think about it ahead of time. Otherwise, we will do this together when I see you next.